Today we're going to be talking about how to rationalize the denominator. We're going to be working with complex numbers and also radicals. Rationalizing the denominator really means that we are going to get rid of, in a mathematical way, radicals and i's in the denominator. So we're going to look at 3 or 4 different cases. The first case we're going to look at is when you just have a radical term in the denominator. Here's an example. If I have the square root of 15 over 4 square roots of 6, notice that there is no addition or subtraction in the denominator. It's just a radical term. So what we're going to do in order to rationalize that denominator is we are going to multiply that fraction by the radical in the denominator over the radical in the denominator. Because remember, it's fine to just multiply by something as long as it's a 1, and by putting the same thing over itself, we're really just multiplying by 1. So we look at this denominator. The radical part of the denominator is the square root of 6. So we're just going to multiply by the square root of 6 over the square root of 6. Now, multiplying the numerator, we have the square root of 15 times the square root of 6, which is really the same thing as doing the square root of 15 times 6 all under the radical, which will be the square root of 90. And then over, we're taking 4 square roots of 6 times the square root of 6. And when you do that, you're really multiplying the coefficients, 4 times 1, so 4 times 1 on the outside, and then inside that radical, 6 times 6, the two radicands. Well, we know that 6 times 6 is 36, and the square root of 36 is plain 6. So what we have in our denominator is really 4 times 6. We're going to want to simplify the square root of 90. Since 90 breaks down into 9 times 10, you can take that 9 out. The 9 is going to turn into a 3. The 10 is going to stay inside the radical. So the numerator becomes 3 square roots of 10, and the denominator is going to be 24. We want to look and see if we can simplify this any further. And since that 3 in the numerator, the coefficient, and the 24 in the denominator are both divisible by 3, we'll do that, and we'll end up with 1 square root of 10, or just the square root of 10, over 8. And that is as simple as that problem gets. So on our steps, we want to multiply by the radical in the denominator over the radical in the denominator, and then we want to make sure that we simplify if possible. Let's look at another example of this type of problem. How about a little bit more complicated? 3 square roots of 7 plus the square root of 2 all over the square root of 5. Again, this denominator only has a radical term, so we're just going to multiply the numerator and denominator both by the square root of 5. So I have times the square root of 5 over the square root of 5. It's helpful to go ahead and put a parenthesis around your numerator so that you will remember to distribute that square root of 5 to both terms in the numerator. So when I do that, I'll have 3 times the invisible 1 is 3. And then under the radical, I have 7 times 5, which is the square root of 35, plus the invisible 1 times the invisible 1. We'll leave that an invisible 1. And then the square root of 2 times the square root of 5 would be the square root of 10 all over. The square root of 5 times the square root of 5 is the square root of 25, which can be simplified to just regular 5. Now we want to check and see if 35 or 10 can simplify in those radicals. 35 breaks down into 5 times 7. Neither one of those is a perfect square. Neither one has a partner to get out of the radical, so they both have to stay in. So that square root of 35 will not simplify. And the square root of 10, similarly, would be 2 times 5, which also will not break down, so the 2 and the 5 both stay in. So the square root of 10 will not simplify. Now you might be tempted to simplify this 35 with that 5 or that 10 with the 5, but it's very important to remember that you cannot simplify a number outside the radical with a number inside the radical. Let's make ourselves a note. You cannot simplify a number outside the radical with a number inside the radical. The second type of problem that we're going to look at is when you have a more complicated denominator that has a sum or difference with a radical in the denominator. An example of that type of problem would be 4 square roots of 3 minus the square root of 2 over 7 plus the square root of 5. This denominator this time has a sum in it. So what we're going to want to do is multiply by the conjugate of the denominator. And since we just can't multiply by something unless it's a 1, we want to make sure that we're multiplying by the conjugate of the denominator over the conjugate of the denominator. So we're going to multiply by the conjugate of the denominator over the conjugate of the denominator. This is why we practiced finding conjugates the other day. When I look at this denominator, 7 plus the square root of 5, the conjugate of that is going to be 7 minus the square root of 5. So I'm going to multiply by 7 minus the square root of 5 over 7 minus the square root of 5. Again, it will be helpful if you'll put your sum and differences in parentheses. Now notice that this is an operation we've already had some practice with. Multiplying these sums and differences is just going to be the process of foiling. So we're going to want to FOIL both the numerator and the denominator. So we have two foiling problems to do here. In the numerator, first times first, we'll have 4 times 7, which is going to be 28, and then we keep that square root of 3, so 28 square roots of 3. And then outside times outside, 4 times invisible 1, negative 1 at that, will be negative 4. And then square root of 3 times square root of 5 will be square root of 15. Inside times inside, we have invisible negative 1 times 7, so minus 7. And then a square root of 2, so negative 7 square roots of 2. And last times last, we have a negative times a negative, which makes positive. Square root of 2 times square root of 5 is square root of 10. Then on to the denominator. First times first will be 49. Outside times outside, we have 7 times invisible negative 1, so negative 7 square roots of 5. Inside times inside, 7 times invisible 1, and then that square root of 5, positive 7 square roots of 5. And last times last, positive square root of 5 times negative square root of 5 will be negative 5. Now, if we've done our foiling correctly and chosen the right conjugate, in the denominator, these two terms that have radicals will add to 0. So what you'll end up with in your denominator is a number with no radical, which is what we've got. 49 minus 5 is 44. Now in the numerator, we'll also combine like terms. This numerator has a term with a square root of 3, a term with a square root of 15, a term with a square root of 2, and a term with a square root of 10. None of these will break down, and none of them are like terms, so we're just going to leave that numerator exactly how it is. It's a little on the long-winded side, but it is correct. That is as far as this can go. I would also check to see, can this denominator simplify with each term in the numerator? Now I could simplify the 44 with the 28 because they're both even, and the 4 because they're both even, but 44 and 7 won't simplify, neither will 44 and 1. And in order to simplify with addition and subtraction like that, I would have to be able to take the same thing out of the denominator as I can out of each 4 of those terms. So that is simplified. Might want to add that step over here. After we multiply, then we're going to want to simplify. Let's do another example that's similar to that. This time it's going to look like 8 square roots of 5 plus 6 square roots of 2 over 3 square roots of 2 minus 4 square roots of 5. Since I have an addition or subtraction problem in the denominator with radicals, I am going to want to multiply by the conjugate. In this case, I can just change that subtraction to addition, so it will be 3 square roots of 2 plus 4 square roots of 5 over 3 square roots of 2 plus 4 square roots of 5. Now go ahead and add in those parentheses. And the next step will be FOIL the numerator, FOIL the denominator. In the numerator, the first term times the first term, I'll have 8 times 3, 24, square root of 5 times square root of 2, square root of 10. 24 square roots of 10. And then outside times outside. 8 square roots of 5 times 4 square roots of 5 would be 8 times 4, which is 32. And then square root of 5 times square root of 5 is regular 5. Inside times inside. 6 square roots of 2 times 3 square roots of 2. 6 times 3 is 18. Square root of 2 times square root of 2 is regular 2. And then last times last. Positive 6 square roots of 2 times positive 4 square roots of 5. 6 times the 4 is 24, and square root of 2 times square root of 5 is square root of 10. In the denominator, first times first, 3 radical 2 times 3 radical 2 is 9 times regular 2. Outsides, 3 square roots of 2 times 4 square roots of 5 is 12, and then square roots of 10, plus 12 square roots of 10. Inside times inside, negative 4 square roots of 5 times 3 square roots of 2 is negative 12 square roots of 10. And last times last, negative 4 square roots of 5 plus 4 square root of 5 is minus 16 times regular 5. We're going to simplify and combine like terms. So in my numerator, square root of 10 will not break down, but 32 times 5 is going to make 160. 18 times 2 is going to make 36. And I have another 24 square roots of 10 that will not simplify. So the numerator, I'll combine these two like terms and make 48 square roots of 10 plus 196. In the denominator, 9 times 2 is 18. 12 square roots of 10 minus 12 square roots of 10 adds to 0. And 16 times 5, negative, makes negative 80. So I have 18 minus 80, which makes negative 62. Now it's time to simplify what I have here. And again, I want to check to see, can I take the same number out of each of the three terms or coefficients of terms? And the answer to that is yes this time. All of those numbers are even. Since they're all divisible by 2, I'm going to go ahead and take a 2 out of each term. And I will usually indicate that by just going divide by 2, divide by 2, divide by 2. Remember, you cannot simplify a number inside the radical with a number outside the radical. So that square root of 10 is going to stay just how it is. Taking that 2 out of every term, I have 24 square roots of 10 plus 98 all over negative 31. Now we're almost finished. This negative 31 in the denominator, whenever you see that happen, what you'll want to do is put the negative, instead of in the denominator, move it to out front. So we'll have negative, and then the fraction 24 square roots of 10 plus 98 over 31. You could also write this negative 98 plus 24 square roots of 10 all over 31. The third type of problem that you will be rationalizing denominators for are problems that have complex denominators. And those are problems that are going to have i's in the denominator. Here's an example. 4 over negative 9i. These are going to be handled almost exactly the same way as problems with radicals in the denominator. You are going to want to multiply by the complex conjugate of the denominator. Over the complex conjugate of the denominator. If you remember from the last time that we talked about complex conjugates, a complex conjugate, just for reminder's sake, is in that form a plus bi and a minus bi. So we want to keep the real parts the same, change the sign of the imaginary parts. So in our example here, 4 over negative 9i, the complex conjugate of negative 9i is positive 9i. So we're going to multiply by 9i over 9i, which will be 4 times 9i is 36i, and negative 9i times negative 9i is negative 81i squared. Also, the other day when we were working with these, we discovered that I squared is negative 1. So remember that we were going to automatically replace any I squared with a negative 1, which has the effect of just changing the sign of that denominator. So really we have 36i over positive 81 with no i's on that. So there's our next step, is to replace any I squared with multiplying by negative 1. And then, of course, we want to simplify if possible. So we're going to look at this fraction. Is there any number we can divide out of 36 and 81? And yes, there is. It's 9. So that 36i divided by 9 is going to be 4i over 81 divided by 9, which is 9. And the way we're going to write those fractions with i's is we're going to write 4/9 and then the I out next to it like that. So that is going to be our answer, 4/9 I. Let's look at another example that's a little bit more complicated. 1 minus 6i over negative 8 plus 2i. We're going to have that same first step that we are going to multiply by the complex conjugate of the denominator over the complex conjugate of the denominator. The denominator is negative 8 plus 2i, so the conjugate of that will be negative 8 minus 2i. And we need that in the numerator and the denominator. It's helpful again to go ahead and make your two sets of parentheses in the numerator and two sets of parentheses in the denominator. Then we're going to be foiling the numerator and foiling the denominator. So as we go, first times first, negative 8, outside times outside, negative 2i, inside times inside, positive 48i, and last times last, positive 12i squared. In the denominator, first times first, positive 64, outside times outside, plus 16i, inside times inside, minus 16i, last times last, minus 4i squared. Again, when you have those I squareds, that's just going to replace that term with its opposite, so negative 12 in the numerator and positive 4 in the denominator. And then we'll combine our like terms and write these in standard form. So that is going to be negative 8 minus 12 is negative 20, and negative 2i plus 48i plus 46i over, remember that when we multiply two conjugates, that I term should drop to 0 and we end up with a real number. So we have 64 plus 4 gives us 68. We want to check and see if we can divide the same number out of all three terms. And there is a number that can come out of all three of those terms. We can divide a 2 out of each term. So that would leave us now with negative 10 plus 23i all over 34. And then when you have a problem that has that format, we're going to write a big star over here because it's kind of important. If you end up with a complex number like a plus bi over some other number c, we're going to rewrite it as a over c plus b over c times I, and then simplify both fractions. It takes a little getting used to, but it's not that difficult once you get some practice at it. So here we have negative 10 plus 23i all over 34, and we'll rewrite that as negative 10 over 34 plus 23 over 34i. And we want to see if we can simplify those fractions. The 10 and the 34 still have a 2 in common that we'll divide out. The 23 and 34 are already simplified. So when we finish this problem, we'll end up with negative 5 over 17 plus 23 over 34i.